This instructional video will demonstrate how to take an isotope symbol and determine the proper number of protons, neutrons, and electrons in it, using simply the information given. The important thing to remember is that the mass comes from a sum of protons and neutrons. These are the more massive particles within an atom, and the proton and neutrons have masses that are roughly equivalent. The other thing to remember is that the charge is the result of a difference between the number of protons and the number of electrons. While the electron has mass, it is relatively tiny compared to protons and neutrons. But it does have a negative charge, and so we pick up -1 for each electron, as compared to picking up +1 charge for each proton. And so the difference between those two numbers will determine the overall charge in our atoms. So, the first thing we have here is calcium. We have an isotope with a mass of 41 atomic mass units and a charge of +1. We look on the periodic chart to get the atomic number of calcium, which is 20. That corresponds to the number of protons. 20 plus something gives us mass of 41. So we have 21 neutrons. A +1 charge means that there is one more proton than there are electrons. So our electron count is 19. We'll do the same thing for the other 5. Oxygen has atomic number 8. 8 plus 8 gives us 16. And 8 minus 10 will give us -2. Fluorine has atomic number 9. 9 plus 16 gives us 25. And in order to have a -1 charge, I need one more electron, so that's 10. For cobalt, the atomic number is 27. 27 plus 38 gives us the 65 atomic mass units, and 26 electrons will balance out all but one of our protons. Nickel has atomic number 28, and 28 plus 37 gives us 65, and we expect 26 electrons to balance out all but 2 of the protons, leaving us with a 2+ charge. For platinum, the atomic number is 78. 78 plus 121 gives us 199. And in order to have a -2 charge, I will need 80 electrons. So this process of looking at the symbol, finding the atomic number to get us our number of protons, and then using that in combination with these two pieces of information is what allows us to find the number of protons, neutrons, and electrons, given an isotope symbol.